So let's keep ourselves here with chapter 1, section 10, and it's just called lines, and it's straight lines is what it's called, and those would be described as first order equations. So you've got just y equals something on the right hand side that has constants and it has x in it. And it's not x squared, that would be second order. Right, so it's just a first order equation. And so there's two different forms. One is the slope intercept form, and the other one is the point slope form. So we will work with both. I'm going to kind of start with the one that I'm familiar with a little bit more from my engineering background. So it's y equals mx plus b. And so the need here is to find the constants m and b, so those do not change. The variables are x and y. So your independent variable, your dependent variable. And so the slope, right, m, that describes the slope of the line on the page. And b is the y-intercept. So we'll get more into that. So this is the slope-intercept form. And well, I became interested. YM. And so I did a little search, and it was traced back to a treatise on geometry by British mathematician Matthew O'Brien. And that was back in about the 1850s. Actually early, sorry, about 1810s. Or somebody else had claimed that it was all the way back in 1757 with an Italian mathematician. And so they were using the symbol M, and one way could go back all the way to the Latin, and the Latin for mountain. And so the slope, sort of describes, could be seen as the side of a mountain, the slope of a mountain. And so the Latin word, I'm going to forego pronouncing that. Also, m could be modulus of the slope. So the modulus is a constant. In other engineering, like the modulus of elasticity would be described for certain materials. So, however, it is just traditionally known as M. And so what we're dealing with here are 2 points. And these 2 points create a line. And to find the slope, what we do is we're just going to subtract the y's over the x's. So if you think of it as point 1 and point 2, there's a y1 and a y2. And so if I subtract those, y2 minus y1, I have to do it on the bottom the same. So the slope is also described as the rise over the run. So the rise is in the y direction, the run is in the x direction. And as often we see in here, it doesn't matter what order you do this in, as long as it's consistent. So you could also do it y1 minus y2 divided by x1 minus x2, and you would get the same answer. So the order wouldn't matter as long as it was consistent, top and bottom. So I would encourage you to take a look at page 107 in your book. Slope of a line is described, and that line is an infinite number of points. So we're kind of doing two things here. One, we're taking 2 points to make a line, and once we have that line is an infinite number of points. So 4 possible classes that you see on page 107. So 4 classes of different slopes that can show up. So I'm just going to go back here to the slope-intercept form. And if we're looking for the y-intercept, so the intercepts keep popping up here. So the y-intercept, right, where it crosses the y-axis. That, by definition, would be when x equals 0. So all we're going to do is take this equation right here and plug in x equals 0, which cancels that term out. So we just get y equals b. Right? And so if we want to do it in coordinate form, it would be 0, comma b. So the x-intercept would be when y is equal to 0. So we're going to go into this equation and plug in y equals 0, giving us 0 equals mx plus b. And then we're just going to solve for x. That'll give us the location. So it's negative b over m. So the location of the x-intercept is going to be negative b over m, comma 0. So that's the location where the line crosses the x-axis, intersects the x-axis. So as you kind of look at this here, you would see that, when this is true, right, or that gives us a point, except when m is equal to 0. So we'd have a little bit of a problem there. We'd have a infinity right here. So a line with 0 slope would be parallel to the x-axis, or it would be sitting right on top of the x-axis. And so we'll learn, as we go through this class, we'll end up doing what we're actually doing is called curve fitting. And so what we're fitting is a first order curve to 2 points. And so you, by definition, 2 points can create a line, right? And that line will have to be straight. Now, you could create curve lines that go through those 2 points, but those would be non-unique. You would have an infinite number of answers that could do that. But you only have one answer for a straight line that goes through 2 points. So it deals with uniqueness. So we'll kind of get into that. And as you look at the end of chapters, they have this neat modeling, bunch of modeling problems. And so what they do is with like 20 data points, they fit a straight line to it. And so you can't go through, most likely you won't be able to go through all 20 points with a straight line. So there's a technique of how you minimize the error. If you have 2 points, you can always draw a straight line between those 2 points and extend it past. So that would be what we would call, and there's only one answer for that. So the other form that we use is called point slope form. And so you can use point 1 or point 2. Remember, you have 2 points. And so one way is y minus y1. And then on the other side, sort of m is equal to x minus x1. So if we solved for m, it would look like the equation for the slope. It would look like it. But these, right, this x right there and that y right there, those are variables. Those are not points. They're not like sub 2. So these are not points. Those are the variables. So that's where that's a little bit different. It is not the same. If you go back and look at the slope equation, the slope equation involved x1 and x2 and y1 and y2. So this equation has y and x, the independent and the dependent variable in it. So at this point then, you could just reshuffle the equation and it could end up in any form. So if you wanted to use point 2, then very similar, just y minus y2 is equal to m times x minus x2. So go ahead and take the equation. This is a equation of a line. And so it's just in the form, we've got an x and a y, right? There's no squared anywhere, so this is a straight line. And you're asked to find the slope and the y-intercept. So what I'm going to do is put this thing in the form of y equals mx plus b. When we do that, once we do that, that's the slope and that's the y-intercept, so we'll have our answer. So I'm just going to take this equation, and I'm going to take 4 and I'm going to add 4x to each side. And so I'm close. I just need to divide each side by 3 or multiply by 1/3, however you want to think of it. And so we end up with y equals 4 over 3x plus 7 over 3. So the slope would be 4/3. The intercept would be 7/3. All right, and then quickly, perpendicular lines. By definition, those two perpendicular lines, they are perpendicular when you take their slope. So this is line 1 slope, that's line 2 slope, and you multiply them and you get -1. It's also known as orthogonal. So those lines would be orthogonal to each other. That's kind of a fancy way of saying perpendicular, so you can impress some people with that. Perpendicular lines have slopes that relate, and you could just solve this here. So this is just another way of representing the fact that when you multiply the slopes together, you have to get -1. And this just says that the slope of one line is equal to the negative reciprocal of the other. It doesn't matter where 1 and 2 are. All right, so we'll kind of end on this one here. Got some bread dough is left to rise. It's a word problem here. Its volume in cubic inches, so this bread dough has some volume, right? T minutes after it is left standing. So the dough is left standing at t equals 0. And the equation for its volume is 2 times t plus 100. And this has units of, this is a volume, so it has units of cubic inches in the end. So this whole term over here, right, when you multiply that together, you have to end up with cubic inches. So let's see if we can think about something here. How about, what's the slope and the y-intercept of that? You might want to jot this down on a scratch paper here. Maybe that equation, right? What part A is, find the slope and the y-intercept. Just go ahead and jot that down. And then right there, what do they represent in words? What does the slope represent in words? Like it has a value. The y-intercept has a value, but what do those represent in words? Somebody said, well, so you're saying the y-intercept is 50. Okay, I'll say that. I'll agree, I guess. But what does it mean? What does that mean? Take a minute, see if you can think through that.